All right, rational functions, multiply and divide rational expressions, advanced. All right, so this is basically the same as the last assignment, just with more factoring, or harder factoring at times, I should say. All right, so this first problem, they want us to solve for A. And so before I show you what we're going to exactly do, I'm going to factor all these other three corners, and then we'll talk about it. So this one top left, we can pull out a 6k. K minus 6 left over, and we'll leave that over our original A, times, this would be K plus 6, oops, it's too small, times K plus 6, and that's the difference of two squares, so K plus 6 times K minus 6. Now, equals 1. Now remember, if you ever have anything over anything, the same thing over the same thing, it's going to equal 1. Like 4 over 4 equals 1, 2 over 2, infinity over infinity, K plus 6 over K plus 6 is equal to 1, which is why we're able to cross certain things out. Okay, so we're going to do that right now and see what we're left with. Well, up top we have a 6k times K plus 6, which is equal to that. And the entire expression is over A, and it's equal to 1. They want us to figure out what A has to equal for this to equal 1. Well, A is going to equal what is on top that's left over after you go through cross everything out. So our answer for the first question is 6k times K plus 6. And there we go. All right, question 2. I'm going to pause this and just save time. All right, next question. We have a divide problem. So we're going to flip this second expression, or second half of the expression. So this will go on top, this will on bottom. I have not done that yet. Okay. So I'm going to first start factoring this top up here. We cannot factor a 2 or a 3 because 13 is prime. So we have to go straight into the diamond method. Let's do it down here and erase when needed. 6 times 6 is 36, and 13. It's 9 and 4. Okay, reverse box method because our A is not 1, it's a 6. So 6y squared goes there, 6 here, and 9y and 4y. All right, factoring up, we can pull it both even, so 2 can come out and a y. 2y times 3y, 2y times 2, and 2 times 3. So our top is going to factor into 2y plus 3 times 3y plus 2. All right, let me erase all this work down here. All right, the bottom, I'm going to flip this around first. So negative 5y plus 20. It's not in standard form. And now I can pull out a negative 5. Oops, that's not pulling out. There you go. And then what's left over is a y minus 4. All right, so division, remember, so we're going to flip it and multiply. So this is going to go on top now. This one I can easily factor in my head. It's going to be y minus 4 times y plus 2. And this up here is the difference of two squares. 4y squared, the square root of that is 2y, and the square root of 9 is 3. Remember, 1 is plus and 1 is minus. All right, so let's go through and see what we can cancel out. Looks like we have a 2y plus 3. Ooh, this guy's dead. All right. There we go. So 2y plus 3, 2y plus 3. Y minus 4, y minus 4, and that's it. So we have left over 3y plus 2 times y plus 2 all over negative 5 times 2y minus 3. I'm going to pause this while... Okay, I typed it in and we were right. So next question. Question 3. All right, so this has it's a division problem, and there's 2 variables in here. So it's going to look way more complicated than it really is. If you take it slow, it shouldn't be a big issue. Okay, so we'll have to flip this eventually. First, I'm going to start with this top left. What can we factor out? There's nothing we can factor out of all of it. I want you to pretend there's no z's here. So if we were to erase this z and that z squared, what would you do to factor it? Well, it would be x plus 8 times x plus 8. Well, probably x squared here and the x. You see how there's 2 x's and an x? Well, that's what this comes from. It comes from here, x and x, for the first terms. Well, this did have a z. I'll do it in a different color. Oh, I forgot that was the dead one. So z here, and a z squared here. So it's just kind of backwards, which means we're just going to have a z in the back here and there. That's really the only difference here when you have a second variable that looks like that, where the z squared in the middle is the z. Okay. The bottom looks like they both have an x and a z. So I'm going to pull out one x and one z and see what we have left over. Well, xz times x squared z is simply just x. And then xz times what is 8xz squared? That's going to be 8z. And you can see that these are the same, so those will eventually cross off. We have a division problem, so we're going to flip and multiply. So we're going to factor this twice, I believe. So I'm going to pull this down here first. We can pull out 2 x's. There's 2 here and 4 here. And 1 z. There's 1 z and 2 z's, or 3 z's. So x squared and a z. What's left over is x squared minus 9z squared. And you can see now we have a difference of 2 squares. So this can be factored into x minus 3z and x plus 3z. So the bottom down here is going to be x squared, sorry, the top, x squared z times x minus 3z and x plus 3z. Alright, so erase all this, and my mistake. Alright, and then we have to factor this coming down. This is just like what we had over here with the z squared and the z in the backside. So it's factored normally with the numbers, which is going to be 8 plus 5, x plus 8. I'll start doing it. X plus 8 times x minus 3. Oh, z. All right, now let's see what we can cross off. We can cross off, 8 plus, or x plus 8z. We have another one of these right here. And then an 8 minus 3z. And then we have x squared z here and an x and z. So I'm going to cross off the x and the z. And we'll leave one x behind. So our answer is really small. X times x plus 3z. Everything else crosses off. All right, let's see if this operates faster. And question 4, the last one. Okay, just like the first problem. So n squared plus 24n plus 144. That's going to factor into n plus 12. N plus 12. I'm going to just factor straight up right now. So I'm factoring this on the board right now. This will be n plus 12 times n plus 1. Sorry, minus 1. And this will be times n plus, plus 3 times n minus 1. And then our a. Okay, so I factored straight on the board to right here. Now what can we cross off? Boom, 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 boom. What does a need to equal? N plus 12 times n plus 3 is what a needs to equal. N plus 3. And we are done. Just under 10 minutes.